Okay, I'm going to do a quick review of the formula we've been talking about the last couple of days, this V equals omega times R formula. The formula itself is not difficult. You're going to multiply omega and R together to get V, or if you're trying to find omega or R, you would just divide. The key to this formula is making sure that your units are correct and that you know what each variable represents. So V is what we call linear velocity. It's going to have two units associated with it. A linear unit, so something that you would use to measure a line. That's what linear units are. So centimeters, meters, inches, feet, miles, something like that. And a time, minutes, hours, seconds, something like that. So it'll have two units, a linear unit and a time. A linear unit and a time unit. So miles per hour, inches per minute, feet per second, something like that. Then you have angular velocity, which is an angle over time. And remember, angles are measured in revolutions, radians, and degrees. But for this formula, it has to be radians. So if you have revolutions or degrees, you have to convert them to radians in order to use this formula. And then R stands for radius. So real quick, just so you understand what this formula is. Oh, radius is going to have, linear units. They have to be the same linear units as V. And V and omega have to have the same time units. And omega has to be radians. So there's lots of requirements for the units. Now, real quick, just to kind of explain what's going on with this formula. What this formula says is that when something moves in a circle, it has two types of velocity. It has the linear velocity, which is basically how far it walks over time. And you can see that this is going to be related to the circumference of the path that it walks or moves or whatever it does. The more times it goes around, the further the distance it's going to walk. Okay? So that's the linear velocity, the distance that you travel in a certain amount of time. Then angular velocity is the angle that you travel in a certain amount of time. So at the same time that you're walking a distance, you're also walking an angle. Every time I go around, I'm walking the circumference of the circle, and I'm also going one revolution, or 360 degrees, or 2 pi radians. And so that's angular velocity. And your linear velocity depends on your angular velocity and the radius. The bigger the radius, the further you're going to walk. The bigger your linear velocity is going to be, right? The smaller the radius, the shorter the path that you walk is, and so the smaller your linear velocity. So these three ideas are related through this formula. So let's look at some examples here from what we did in class today. So some of these, all we're going to be doing is some unit conversions, and some of them will be using the formula. For example, this says find the angular velocity. Oops, hold on, I got to turn my pen on here. Find the angular velocity, so that's omega, in radians per minute associated with 30 RPM. That's revolutions per minute. That's omega also, right? So they're telling you to find omega, but they give you omega. That's because they're not really asking you to find omega. They're asking you to find omega in radians per minute, but they're giving it to you in revolutions per minute. So this is just a matter of converting from 30 revolutions per minute to radians per minute. So converting revolutions to radians. And there are 2 pi radians in one revolution. So 60 pi radians per minute. Okay, so you'll have a problem on your assessment tomorrow where that's all you have to do is convert the units for omega to radians per minute. Because remember, we talked about that in order to use the formula V equals omega R, omega has to have its angle measurement in radians. So this is just having you practice that, getting omega in the right units. Okay, let's look at the next one. A record player is turning at 8 radians per second. 8 radians per second. You've got radians, which is an angle measurement, and seconds, which is a time measurement. So 8 radians per second, that's omega. Find the linear velocity in inches per second. So they're telling you to find v in inches per second of a point on the edge of the record if the point is located 5 inches from the center. So notice, inches for r, inches for v. So that works. Seconds for omega, seconds for v. So that works. So all of our units are right. So we can just plug straight into this formula. Omega is 8, r is 5, so v would be 40. And we multiplied radians per second by inches. This is why radians are so much better than degrees or revolutions. Radians are actually unitless. We call them radians so that they can be called something, but the minute you combine them with another unit, they take on that unit. So when I multiplied radians per second, which is what this 8 was, by inches, which is what this 5 was, it became inches per second, which is what they asked me to find. So 40 inches per second. So these are both pretty basic examples of using this formula and also doing some unit converting. I'm going to do one that's a little bit more involved than either of these, but not too involved, and these are very similar to what will be on your assessment tomorrow. So let me pick another one off of here. Hold on. Okay, so let's look at this one. Find the linear velocity, so find v in feet per minute, of a point rotating at 15 RPM. RPM means revolutions per minute. Revolutions is an angle measurement and minutes is time, so that's omega, on a circle of radius 3 feet, so that's r. Notice feet and feet, minutes and minutes, so all of our units are good except revolutions has to be radians. If you look in the foldable we made, the purple one, under omega, it says to use the formula, omega has to have an angle in radians. So before we start, we have to change 15 revolutions per minute into radians per minute. So we have to cancel revolutions and get radians. And there are 2 pi radians in 1 revolution. So 30 pi radians per minute. That's our omega. So now it's got the right units. It has the right time units. It already had the right time units. Now it has the right angle. So now to get v, we just do omega times r. And we get 90 pi. And remember, we were multiplying radians per minute by feet, so we get feet per minute. Okay. So try this next one. I'm going to pause the video. You pause the video on your end too, and I'm going to work it out, and then we'll see how you did. So pause the video real quick, and then we'll go over this next one. Okay, so how'd you do? You should have gotten 70 pi inches per second. So if we go back through, they said find the linear velocity, that's v, of a reflector located 10 inches from the center, that's r, of a bicycle wheel, rotating at 7 pi radians per second. So you had an angle measurement, radians, and a time measurement, seconds, that's omega. And omega has to have an angle in radians, which this one did, so you didn't have to do any converting first. So you just had to plug into the formula. V equals omega times r. You got 70 pi. This was radians per second, and this was inches. And so when you multiply radians per second by inches, you get inches per second. So I hope you feel a little bit better about this formula. This is pretty similar to what you'll see on your assessment tomorrow. So if you have any questions, you can come in before school tomorrow. Or if you have a quick question, you can ask me right before the assessment starts tomorrow. So hope that helps.